and welcome to the program. This is our first episode of the discussion group. The ambition of this show is to have a thoughtful conversation on a variety of topics, from life to science, music, art, culture, to even bartending. We won't pretend to be experts on a subject, but rather we take the approach of being individuals who are naturally curious about the world and have a zest and a sense of illumination by talking about things. If in the future we can have a professional from the field join us, then we certainly welcome that, and we welcome comments and suggestions from our viewers. So with that, gentlemen, thank you for being on the program.
Thanks for having us.
Yeah. Oh, there is one program note. Matt Doucette is away at a bar in Newport. Okay. So for our first topic for our first show, I thought we'd start out with something sort of light and easy. And this is a favorite topic of mine. I know we've discussed it usually at a bar.
Yep.
And it's an easy topic. It's the creation of the universe and what its fate may be. And I have some PBS clips from over the years lined up, and we'll take a look at some of those. And I have one to start us off with, and we can talk about it. But that's the topic. Before we see the first clip, do you guys have any comments about the show, the topic, before we watch?
So you're starting us something real easy.
We'll just go for the whole enchilada.
Yeah, just what about the universe? Okay.
We are supposed to keep this under an hour, right? That's
like 8 hours later.
Yeah.
And then if you look at all right, well, let's take a look at the first clip. I think this sort of will get us started. This is a clip about the Big Bang, and we'll go from there.
Okay.
So let's take a look.
How did the universe arise? What was around before that?
The current scientific story of the origin of the universe begins with an explosion which made space itself expand. About 15 billion years ago, all the matter and energy that today make up the observable universe were concentrated into a space smaller than the head of a pin. The cosmos blew apart in one inconceivably colossal explosion, the Big Bang. And the stuff of the universe, together with the fabric of space itself, began expanding in all directions as they do today.
We have a pretty good understanding of the history of the universe from 1/100th of a second after the Big Bang until today, 15 billion years later. And it's pretty remarkable that I can say this, and it's even more remarkable I can say it and the men in white coats don't come and pull me off the stage. And I think that part of the history we have pretty much nailed down, because there are fossils and relics that are left behind that tell us that our theory is right.
So there we go, the Big Bang. I think it's fascinating that he was saying that physicists, cosmologists can figure out what happened in a scientific way up to 1/100th of a second after the Big Bang occurred. That to me is like mind-boggling. How, that's incredible.
Yeah.
A species such as us.
I guess I think of it as like, I think later some of the stuff you kind of, brought up for us was to like kind of look into this was about like looking backwards in time, right? Like, and being able to see the light. So like they're looking back, and so they can see it. Which was, I think it's just amazing that they can actually like kind of see the timetable backwards like that. Do you know what I'm saying?
Right.
Like because the light is still kind of like spreading out, so they can kind of still see how the Big Bang happened. I think what I find it kind of crazy about all of this is that there's this moment though right up to that, right, where like it just like you can't get it,
Right.
so like, but that is pretty amazing that you can actually
That we
even
can figure
see that
this
far back.
Yeah, that we figure it out that close. You think
It's
that
pretty nuts.
we are a
Yeah.
species that, let's face it, like 15,000 years ago, we're hunter-gatherers. And now look at us. We have sent probes out into space, and we can figure out through science how the Big Bang occurred, well, at least almost.
Yeah, and I think based on seeing that video, the first thing that sort of repeats in my mind is, and I know a lot of people think this is, okay, so it originated from mass that was the size of a pinhead, as
Right.
Carl Sagan says. But okay, what was there before?
Yeah.
And so, and I refuse to think, or I can't really think that there was nothing, because it's hard to conceptualize nothing. So what was it? And I think this will be covered in maybe one of the future clips as well.
Yeah.
But
How do you get something from nothing?
right.
How,
Yeah,
how
that
it-
was the thing
it's
that
hard for
really
us
gets me.
to sort of grasp that, you know?
Yeah.
Well, I think even the whole thing is like kind of insurmountable. I wanted to kind of mention that because it's like 15 billion years ago.
Yeah.
Everything's a pin size. You're like, what? You like?
Yeah.
That's like pretty. I mean, you can say those things and they're conceptual, so it's like, okay, I kind of understand
Right.
what you're saying
Mhm.
in that analogy, but truthfully, the numbers are like exaggerated to a point that it's just like,
Sure. Yeah.
whatever. Like, I don't know, you know?
Yeah.
Practically forever ago, and maybe once it happens.
Yeah.
Like, you know?
But that's all it takes is only once.
Right.
And there's one, and maybe we can show this in a minute, but there's one clip.
Yeah. Yeah.
Timothy Ferris, he's a science writer, a journalist, and he did a show where he used a lighthouse as an example to show how far we've come to understanding how the Big Bang happened. And he climbs up the spiral stairs of the lighthouse, and each window is, okay, here we are 1 million years after the Big Bang. This is what the hydrogen atoms were doing. They were condensing in the stars. And he got to the very top window, and it was like 1/100th of a second after the Big Bang. And that window's barred up, and he's trying to open it. And he's explaining, well, this is where we've been stuck for a while at 1/100th of a second. And I think he was saying, I read this in an article, there are 4 forces in nature. There's the electromagnetic force, the strong nuclear force, the weak nuclear force, and gravity. And the problem was, how do you get those forces in such an extreme environment that it must have been at the 100th of a second to work, and that's where they've been stuck.
Yeah, I remember that clip when you showed it, like you sent it to us.
Let's take a look at that. So
Sure.
the view, okay, so let's take a look at that.
We've reached the first instant of time. The fraction of a second that has elapsed since the universe began to expand is so small that it has no name. To express it, you'd have to write a decimal point and then a string of 40-some-odd zeros. The universe, everything that there is or can be, was contained, we think, at this point within a single spark of energy, rapidly expanding, but still smaller than the nucleus of an atom, and ruled by a single primordial law. If we knew what went on at this epoch, we might finally understand the relationship between the laws of nature and between space and time and matter and energy. But we don't yet know. We lack a theory that can explain how nature would have behaved under these extreme circumstances. A lot of people are looking for such a theory. Some think it'll be a kind of quantum gravity, or what's called a superunified theory, or a supersymmetry theory. And of course, we don't know what the theory will say. But whoever hits upon that theory will be the first to have glimpsed the very threshold of creation.
Probably the most fundamental question that we can ask about the universe is, what got it started? Where did it come from? The moment of creation. And that's probably the most difficult thing to try to answer. Because in cosmology, the way we reconstruct the history of the universe is to run the movie backwards. The way we run the movie backwards is by using the laws of physics. The laws of physics that we presently know are probably good enough to take us back to within 10 to the minus 43 seconds of the bang, or the moment of creation. That's pretty close. But in order to go all the way back, we've got to get a better theory of gravity. We need a quantum theory of gravity. And I suspect that we may always find ourselves in this position, that to go that last tiny fraction of a second, we need some knowledge that we don't have. And so I think it may be a very long time, if ever, before we can answer the question that everyone would like to know. What caused creation?
Wow.
What caused creation? Jeez.
That's a
Heavy
heavy subject, yeah.
question. Think back to that point of like that unified law idea, you know, okay, so everything's in one place, and I guess that guy, was it Michael
Turner, he's a
Yeah.
cosmo, yeah.
touching on it too, with, you know, needing to understand gravity better, but like, I love the way the other guy in the Lighthouse frames it. It's like, at one point, all of it makes sense to be there, right, in that pin spot before this explosion of like existence, right?
Yeah.
So it's like, oh, yeah, at some point, we don't have the information yet. But at some point, you're going to hopefully, right, discover the information that makes it all make sense, you know? Which is pretty, like, it's just amazing thought. Like, you can wrap everything up into one place, and then basically it all makes sense. Like, weirdly enough, it makes sense even then, even though it's so complex.
You know, and I think Michael Turner hit on something. Let's say we get, instead of 100th of a second, we get a little bit more information, and then we're a little bit closer. That there's always going to be, it's just going to go on forever. We're never going to quite get there. There's always going to be some new thing to figure out. It's just like, it just keeps us working and working. You know, why do we do it? Why? Because I think it's a natural curiosity of human beings. We want to know why did this happen? Why?
Well, it's the reason why they've been doing so much work at CERN, right? I mean,
Yeah.
they've been trying to replicate what it was that created that, again, that gaseous bubble or that huge grouping of matter, or small grouping of matter, it sounds like, to explode forth and create the galaxy as we know it. It is interesting that it is ever expanding, so it seems like they can sort of track it back to its origins because it just continues to move forward. But at the same time, it makes you wonder, was it just the result of some other system failing?
Interesting.
And again, it kind of goes back to my thought of there just being nothing and then there being something and having difficulty reconciling that. The only thing that I can really think of that you can make out of nothing is like a thought, you know?
Right.
I mean, and with that in mind, it's like, well, if it's as simple as a thought, that almost gives creationists more of a good land
Place to like land on. You know, it's funny too, because I think sometimes they'll say, you'll hear it with the cosmologists or whatever, like they'll say observable universe. So they'll say like the difference between like, there's probably universe space that's just out there. But from what we can see, all goes back to this point. That's what we can see.
For the one we're stuck in.
Yeah.
If there's
But there
something
could
else,
be
we
one.
can't.
Yeah, we can't observe it.
Right.
Therefore, we have to consider the fact that there might be something we can't observe.
And we can deduce that. We can sort of do thought experiments thinking about that. You know,
Right.
That's not evidence proof, but I think it shows us with the ability. It's almost, you have to be abstract with this. It's that sort of.
Like their science is crazy too. Over their math, like it's crazy too. Like it's extremely like it's. I actually don't know enough about it, but I guess I would say I'm gonna assume they're doing some pretty crazy jumping through hoops to get things to work, you know, and like figuring it out. But like it's almost like, I guess in my head you're like, it's science, but it's kind of a different type of science. I assume. You know?
It's kind of.
You're not saying.
You almost have to be creative. You need the creativity and the science to come together
the math,
to try to.
Yeah.
This next clip's my favorite clip. It's Timothy Ferris. He discusses vacuum genesis, and we were talking a little bit about this before we sat down to do the show today. I think we're gonna have a lot to say about this next clip. Let's take a look.
Broken Symmetry, a Robert Wilson sculpture, expresses one of the beliefs of modern physics, that the universe may have begun in a state of perfect symmetry. The theories say that matter froze out of energy while the early universe was expanding and cooling, that form arose from formlessness, like ice crystals congealing in a freezing pond. Perfect symmetry may be beautiful, but it's also sterile. Perfectly symmetrical space means nothingness. As soon as you introduce an object into that space, you break the symmetry, creating a sense of location. There's a place where the object is and other places where it isn't. And out of that comes tumbling all of the geometry of space as we know it. perfectly symmetrical time means that nothing can happen. As soon as you have an event, then you break the symmetry and time begins to flow in a given direction. We live in a universe that's full of objects and events, and that means that the universe is imperfect and that the symmetries in the universe we live in are broken. It may even be that we owe the very origin of our universe to the imperfection of the breaking of the absolute symmetry of absolute emptiness. There's even a theory to this effect. It's called vacuum genesis, and it suggests that the universe began as a single particle arising from an absolute vacuum. Curious as it may seem, this idea violates none of the known laws of physics. We've seen how virtual particles come into existence all the time from a vacuum and then fall back into non-existence. There appears to be no upper limit on the size or longevity of the particles that can be created in this way. It's just possible that there might have been absolutely nothing, out of which came a particle so potent that it could blossom into the entire universe. It's not very likely, but then it only had to happen once. The theory of vacuum genesis is a new idea, and nobody knows whether or not it's true, but it does satisfy two of the criteria of a sound scientific theory. It seems at first so strange that it must be preposterous, and like the universe itself, the longer you get to know it, the more beautiful it becomes.
That one's so insane.
Yeah.
I like how it's definitely theoretical, but it's
Yeah.
like, and I don't know where we are today because whatever that clip's from, right? I have no
That was, I think, from the 80s.
Yeah, so I mean, it's
We might be able-
2018. Who knows where we are now?
That's true.
With it,
Right.
But I do think it's still like I looked it up. I think on Wikipedia, and I was like, oh, okay, it's still there.
Yeah.
Okay.
But it's nuts to think. I love the thoughts that I had around like the particles that just kind of came into existence, time, like that, like absence, right? Like
Yeah.
by having something, then there was also nothing, and then also by having a like creation, now there's a timeline. Like
Right.
it just happened.
Well,
it's so crazy.
But here's the thing. We see now, like I know at the subatomic level, if I'm saying that correctly, within atoms, virtual particles come in all the time. I was reading about this, like Z particles, then they cease to exist, and then something else comes into. It's very quick and it's kind of over with.
Like fleeting.
Right, but it does sort of demonstrate that it is possible from out of nowhere comes some sort of. And here's what's even more interesting. And you talk about dimensions. We live in a three-dimensional world, and we know right, left, we know forward, back, up, down. There might be some other direction at right angles of that, but we can't see that. We evolved on the plains of Africa and this world, and so what we've evolved is what's useful for us here. But there may be a next step, and I think like one of the clips maybe we'll see in a little while is about the balloon, where the galaxies are on a balloon and it blows up. But one suggestion was maybe those virtual particles that come into existence out of nowhere are coming from a dimension we don't see. So that opens up a whole can of other worms.
Well, the idea that energy freezes because the atmosphere around it or the space around it was heating and cooling, and that sort of led to this mass and then the explosion. But what was causing it? What was that reacting to? Like, does something just heat and cool on its own?
Yeah.
Or is it from a certain stimuli that is causing it? What is radiating it to what is causing it to heat? And then allowing it to cool?
And I would probably get there with this, like the expansion stuff
Yeah.
later. But I love this idea that like everything was, I don't know about perfect. I don't know about the perfect symmetry piece of that, But if everything was cooled and just kind of dissipated.
Bless you.
Sorry. Explosion! Yeah.
There's your big thing.
Exactly, yeah.
You just created a universe.
Yes, yeah.
Somewhere.
Yes. So it was not from nothing. My nose was tickling.
That's how it all happened.
Yes.
Mike
Part of-
sneezed, we're all here.
Exactly. God's sneezed, right? No. But everything's cool, everything's dissipated out, right? No, I'll touch on galaxies later, but right, it's all kind of evened out, and then something's introduced, right, that causes it to kind of like pop off again.
Something.
But kind of also too, like we talk about observable versus non-observable. It's like, what if the timeline's like, hey, here's the universe, and it's just really cool now. Not like cool, but like cool.
It's cooling down.
And then it's gotten to this point, and boom, it happens again, and then it kind of goes further, and then it like boom happens again, and it kind of goes further. So it's like kind of always expanding, right? But it's just like how it happens. Like it popping off is a natural phenomenon of just, I don't know, empty space, universe. Right? What is the universe?
Well, I mean, it's what was there before the Big Bang, and vacuum genesis. I kind of like the idea. I mean, who knows if it does have a simplicity, a beauty to it, but how do you get something from nothing? And it's like when you think what was here before the Big Bang, nothing. Okay. When you think nothing, I think like darkness, but not even that, because that's something. Mm-hmm. So it has to be. You have to almost think abstract on this. That there's nothing. You can't even imagine what nothing is. And
there's never nothing in
this. How do you get something from nothing?
I remember when I was like a teenager, it was something like you feel like you had like a massive mental like philosophy. You're like, wow, there's never nothing.
That's right, exactly. Well, it's like you put a lid on a mason jar and you show it to somebody and say, what's in here? And they're going to say nothing. Well, it's not really nothing.
Right.
I mean, there's air in there. What is air made of? It's a gas. And that's the thing. It's not like that space, there was nothing there. There couldn't have been, in my mind. That's why I don't really like that theory, because in my mind, there really could not have been nothing. Like,
what if that's where I kind of got into like the what if it's like a natural progression of a universe to like expand itself out to perfection and flatness,
Sure.
Like everything's just uniform, and then out of that, this kind of was theory. Again, I don't love it because I feel like things are condensing versus a particle just erupting.
Do you think
right? I feel like in the way it's being argued, it's like everything just kind of dissipates, and then out of that comes like a. But it could be a natural, like, I feel like it's whatever the philosophy is, or the theory is, I feel like it's probably a natural phenomenon of universes.
Sure.
Like, they're not, maybe it's all one, but maybe it's just like you said, like there's multiple, and they're all kind of interacted in a way, and they all kind of live and breathe the way a cell breathes, or and how we're greater whole parts. A cell creates organs create.
Right, is the cell aware of us?
It definitely, how would it even check
you have a red blood cell, it doesn't know that this is Tim, and then, there's this, you have thought process. Right. It's just going about it, maybe that's...
like how it works for...
It's very deep. This is a very deep subject.
Well, to bounce off what Tim was saying, I feel like, and the reason why the vacuum genesis theory is a little difficult for me is just with observable nature, what we see on this earth in sort of like a microcosm is we see cycles. We see birth, life, death, birth, life, death. The death produces, nutrients or matter or things that will be recycled into new life.
Right.
So I feel like the Big Bang was sort of the result of that as well. And I feel that symmetry is really what is beautiful, because it's something that it is as consistent as anything. It just happens over and over and over again.
And that kind of is a nice transition that leads into the next part of a clip that we might watch is on the expansion. All right, so the Big Bang happens and we have this expanding universe. And I know 20 years ago, the idea was the Big Bang would expand, and then all the gravity of all those stars and planets and galaxies would eventually slow the expansion down, because gravity would then draw it back in on itself if there was enough matter in the universe to slow it down and bring it in. And then the idea was then a new Big Bang would occur, and then it would just keep occurring. So we might be... there's an infinite number. We're just one of many, and no information trickles through the cusps. But then they found in, I believe in 1998, two independent science teams discovered that the universe is actually expanding, but it's expanding faster which
Like, it's rapidly expanding.
Ra-
It continues to
makes-
expand into raptors.
Yeah.
and it makes no sense. Like the gravity should at least slow it down.
Right.
So if it's expanding and it's going faster, what's causing it? And so this next clip talks about dark matter and how that's the name we're giving to dark energy. Sorry, dark matter is something else. Dark energy is maybe what they're calling it because we don't know what it is, so they call it dark energy. Let's take a look at this clip.
The expansion of the universe was predicted by Einstein's general theory of relativity, published in 1915. But the idea seemed so outlandish that Einstein himself rejected it. He introduced an extraneous term into the field equations to try to make his theoretical universe stand still. Then, in 1929, the American astronomer Edwin Hubble, without knowing of the relativity prediction, discovered that the universe is indeed expanding. Astronomer Alan Sandage, once Hubble's pupil, has devoted much of his career to studying the expansion of the universe.
It is not as if these galaxies are expanding into a space that's already there. The view is that the space itself is expanding, carrying the galaxies with it. The expansion creates the space. It's, well, the crucial analogy first made by Eddington as long ago as 1930, just 1 year after Hubble had announced the expansion, was you can conceptualize the thing as the two-dimensional analog by the surface of a balloon. You paint dots on the surface of a balloon and you blow it up. You put yourself on any dot, you seem to be the center and all the other dots move away from you.
Imagine this universe is expanding. If we blow it up like a four-dimensional balloon, what happens? An astronomer on a given galaxy thinks all the other galaxies are running away from him. The more distant the galaxy, the faster it seems to be moving. This is just what Humason and Hubble found. On the surface of this curved universe, there is no boundary or center. The universe can be both finite and unbounded.
Every place is the center of the expansion. When you talk about this, the question that always comes, well, can you find the center of the expansion? Every place is the center of the expansion. There is no center to the beginning. Everything was back at one place, and every time was identical.
Okay, so actually that wasn't the dark matter clip, dark energy clip. We'll take a look
We
at that
love
in a
dark
second. I know. What is it?
They don't know what that
Sounds
is
like a
either.
candy bar, dark chocolate.
Yeah, it's just my chocolate.
Dark chocolate. But that sets the stage. That's so the expansion of the universe. One of the things, and you guys were talking about it when we were watching it, is that kind of blows your mind is
The balloon, or like the idea that there is no origin of, so that's hard to grab.
no center.
There's no center for this.
Yeah.
There's no for this expansion. It's just that if you think of it as like a balloon and you deflated it, everything's in the center. So
Yeah.
the expansion itself, like you are actually the origin along with
You,
everything
you
else.
can't point. Well, there's the center of it. No, we are the center, which is
Now, do you think that probably has a lot to do with earlier kind of like that fundamental, not full understanding of gravity? Like,
I mean, that would make sense, yeah.
like they're not sure about that piece yet.
the wild part is that the expansion creates the space. So
What?
you have to, the expansion creates, so it's not expanding into something that's already existing. It creates the space.
It's almost upsetting. You know, because it's you know, because it's almost like the feeling of this room. I mean, that this room isn't static. That this room could like just collapse out and just get bigger and bigger and bigger into space that isn't already there. I don't like. That's the thing. I just don't like the idea of just conceptualizing nothingness. But I guess in some way, it's not really something filling the space of nothing that's there. It's really sort of like the balloon analogy. It's just growing and growing and growing, and then within this cocoon, everything inside it just gets more space.
Right.
And
That's existence.
that's existence,
Like,
right?
Right.
But to your point that about nothing, like there not being anything out there, like maybe, you know, maybe like languages are a problem, right? We're like limited in how we framing it, right? Maybe we're limited in how we frame it. Like, I guess I would say, like, for what we know as space-time, that is what's being created. But outside of that, is it really nothing, or is it just back to unobservable? What would it be besides space-time? Our brain doesn't even have a comprehension of.
Yeah.
I don't have a comprehension of what space-time generally, like, I get it, right? The further you go, the more like light there is, with more time you've spent.
More time, yeah. And we're looking back into time.
Right. Because of the light.
Right.
But the thing is, truthfully, like, something's happening in a different galaxy that you're not seeing right now. But if you traveled there,
Right. It's
like,
going to
and
have
looked
long
here,
happen.
you might see dinosaurs, right? Kind of.
Yeah.
Well,
So-
no, the dinosaurs would have been, if we traveled there.
Like, say you went there right now.
Okay, and you look back, the light
'Cause
that
the light
they're
hasn't got
seeing
there.
us through their, yeah.
So, like, space-time is a hard thing to grasp
It's-
for us anyway.
Yeah.
Right, and it's like when you look at the stars in the Big Dipper, I think more or less they're like 75 light years away, give or take. So we're seeing them as they were 75 years ago. If you live to be 75 years old, you'll see what the Big Dipper looked like on the day you were born.
Right.
So it's still,
That's pretty crazy.
you're
It's
looking
pretty
back
cool,
into
actually.
time.
Yeah,
So let's get to the dark matter. Let's get to the dark energy clip, because we want to understand. Suddenly, it's not slowing down,
Right.
which it should. Even if there wasn't enough gravity, you would think it would just gradually get slower until it was like a thin haze. But it's not even doing that. It's going faster. And that is mind-boggling. Let's take a look.
Without doubt, the universe has been expanding since the Big Bang. If there is less than a certain amount of matter in the universe, then the mutual gravitation of the receding galaxies will be insufficient to stop the expansion, and the universe will run away forever.
What if you threw a baseball up in the air and it never stopped? And then not only did it defy gravity, it started racing away faster and faster with nothing propelling it. That's exactly how astronomers felt in 1998, except instead of a ball, they found the entire universe was racing apart faster and faster by the instant. So why would the universe do that? Our best theory is that there's something invisible all around you. And even though you've never seen it, it makes up 70% of the universe. It's called dark energy.
The universe is created somehow from nothing 15 to 20 billion years ago and expands forever. The galaxies mutually receding until the last one disappears over our cosmic horizon. Then the galactic astronomers are out of business. The stars cool and die, matter itself decays, and the universe becomes a thin, cold haze of elementary particles. The death of the universe may seem a little depressing, but we may take some solace in the timescales involved. These events will take tens of billions of years or more. Human beings, or our descendants, whoever they might be, can do a great deal of good in tens of billions of years before the cosmos dies.
Right.
So there you go. Dark energy. What is it, guys?
Dark energy. I mean, I think I've seen the newer Cosmos
Yeah.
too, right?
Yeah,
And
which
that
is
was something
excellent.
he did a great. Was it Neil deGrasse Tyson?
Yeah.
He says, you know, the reason it's dark energy is because they just don't know what it is. It has a really cool name, right?
Right.
And it sounds really like mysterious.
And you know what I
it
like
just
that-
is not like
the
they're not
future
sure what
of
it
the
is.
They're not afraid to, scientists, like, we don't know.
Yeah.
And we're not going to pretend we know.
Right.
Until we know.
Right. Exactly. So we're just gonna call it this thing, which maybe is just too cool of a name for its own good, but
Yeah.
I don't know.
It's,
Go ahead.
I mean, does anybody else get the feeling that when they were first trying to determine what it was that was accelerating everything away from the center, they're sort of like, I don't know.
Yeah.
Wait. Dark energy.
Yeah.
Dark matter.
It's gotta be dark energy.
Yeah, but I mean, I'm sure you guys remember when, I mean, I feel like I followed the creation of CERN very closely.
Yeah.
And do you remember the furor when they were going to turn the Large Hadron Collider on for the first time?
Yeah.
And
You're gonna
there
end
were-
the world.
Yeah, there were the reports where people were holding protests because they thought they could create a mini black hole
Like
and
within it.
destroy the universe, or at least the Earth as we know it.
Right.
And I can understand people's concerns because,
You're playing with stuff that you don't understand.
yeah.
Yeah, that's right.
Well, here's an article I read and that explained this. That's one possibility. This is, again, conjecture, but dark energy may be this. What is forcing the expansion to quickly hurry up when gravity tells us everything should either condense
Yeah.
again or slow down? One idea is we are one universe. Think of us as a bubble.
Okay.
And we are surrounded by multi-universes, also bubbles. We are being pulled by the gravity of the bubbles surrounding our bubble, and that's what's causing the expansion.
Like as it goes
I don't know
faster.
if that's true, but
Right. As it goes faster, it's because it's reaching. It's like a magnet, right?
Yeah.
It's suddenly it actually like is connecting to something and trying. That's pulling it in. At a-
yeah, but that kind of blows your mind too. Like, all right, so we live, so there may be an infinite number of universes, and we're just one. And
I know. I hate to get back in my spot where I'm just like, well, we don't know what we don't know, but it's
Yeah.
like it really is like clearly there's some missing pieces there, right? And like, I think it is gravity. I think it's all it's got to be misunderstandings. That'd be great to ask somebody who knows, right? But like, it feels like that's the general misunderstanding. Like, is that it took me a long time to understand, even as a person, like the idea of a sun, right? Pushing. Think of it as pushing on your
A graph
on your
paper.
sheet, or
Yeah.
whatever. Yeah, on graph paper, right? If you push it down, it creates this like
pucker.
yeah. But at the same time, like that is what the universe is doing, right? Because it's a big balloon.
Yeah.
So it's all strangely connected, and we haven't really touched on black holes at all.
Which
That's another
a,
thing.
That's another program.
Sure. And, like that's a whole nother thing that like there were, like that
Yeah.
are fundamentally misunderstood or hard to understand.
Yeah.
And so it's like, yeah, a dark matter, dark energy, like. Whew.
One other thing that I would describe as sort of upsetting too is the idea that everything expands to the point where almost becomes really thin and stretched, where it's so spread out
Yeah.
that
That's
it
depressing.
cools and everything dies.
I know.
But I really do like the idea actually of the multiple universes that are sort of like these individual little balls or marbles connected, and that's what's pulling people away. Because as I've already said a couple times, I don't like the idea of just the nothingness.
Yeah.
Why does
you
that
know?
bother you, Mike? That's interesting.
Because I have a tough time conceptualizing. Because when you think of nothing, you're still thinking of something. If you think of like a black space,
Yeah.
you're still thinking. Because I think of nothingness as like a black empty space, but who
That's
says
something.
it's even black or empty?
Like
it
space
could
is
be
black and empty, right?
Right.
Right.
That's something,
But that's
right?
It's something.
I mean, even there's like a hydrogen atom every so many points of space
Yeah.
floating around. But yeah, that's something, which is actually because it circles us back to where we started. How do you get something from nothing? And I will be careful with this part of it. But if the Big Bang is our best science, and if you look at that and Sagan discussed this. We didn't show that clip today, but okay, well, how did the Big Bang happen? Well, a lot of cultures, God maybe created the Big Bang or created the universe. And then I think he said, if you're going to be truly courageous, then you have to ask the next question: where did God come from? If you decide that that's an unanswerable question, then he suggests we could save a step and say, well, then right for the moment, the universe's creation is unanswerable. Or if you say that, okay, well, God always existed, then again, you can save a step and say, well, then maybe the universe always existed. There's no need for creator because we can't quite get there yet. And understandably, that will upset a lot of people. And it's not an easy question. The cosmology makes you think about deep things, and that's kind of what we want to do here today anyway. But.
Yeah, some of that's personal beliefs,
Yeah,
It's okay
which is
to
perfectly
have your own
fine.
beliefs. I mean, but back to that point you said, like if it exists. If it is already existing,
Yeah.
right? Then it's like, why does a Big Bang happen? What is this space that we've done it, like so human, But like, what is the space that's been created? Why was it created? Maybe isn't so important, but like, why is it different? Why is it observable? Why is there a wall, right? I think the wall that they have is a heat wall, right? Like they can't see. Do you ever hear this?
Oh, I think I have, yeah.
Yeah, so like when they put the telescopes out there to look further and further back, they just hit a wall eventually with light, because that's the bang, right? So you can't see past it.
Yeah.
So like there's like this weird like space-time thing, right? Where they're looking out into space but can't see further into the universe, but they also can't because there's not enough time, like having passed to see past that explosion.
Right.
Yeah.
So it's like a limiting factor, which is to me, questionable. Right? You say we can make the leaps, but you could also say, is that an important part of it?
Well, I mean, I was listening to a podcast with Neil deGrasse Tyson, and he was talking about one of his fears that keep him up at night is, are we smart enough as a species to figure it out?
No.
And
Mike has the answers.
like we may not have the capacity. There may be, like, let's say there are alien civilizations much smarter than we are. We don't know, but maybe to them we're like the time when we thought that the sun revolved around the earth, and they look at us and like, oh. But his worry is, is our brain structured, has it evolved enough to maybe understand? And that could be part of it. Like, all right, so we're up against this last 100th of a second, whatever. How do we get to that next thing? And we've been stuck on this for a while. I know Einstein was working on it and so forth, but
I guess in the grand scheme, though, we haven't been working on it that long either, right?
This is true. The universe has had a 15 billion year head start, so.
I did joke about it, and I don't want to minimize the very, very intelligent people that have been working on this. My thought is that we do have a lot of very intelligent people, but at the same time, all right, what is our maximum, our lifespan, for example? Let's say it's like, 70, 80, 90 years. So how long does somebody specialize in that field? Well, okay, well, if that person passes away or they retire, there are so many specialties, and there's so many, I feel like, distractions now. I mean, what are the chances that, all right, somebody is going to study something for, let's say, 20, 30, 40 years, and then their research is left behind, and then somebody is going to pick that up and further that research even farther. But I feel like there is a lot of chance, there are gaps there, and I feel like that it's tough because there are so many new things. Every discovery that we make, there are going to be new things, new opportunities to study and discover all these new items. And I just feel like it's going to get to the point where it's so specialized and so segmented that, I don't know,
that nobody's going to understand anybody.
Right, exactly.
Which is why I think it's important. That's why I wanted to have a program like this to discuss about it. We're not going to be those specialists, but if we have a general consciousness of it, an understanding.
And I think I kind of want to touch on what you were saying, Mike, a little bit. It's probably a different subject than space, what we've been talking about. But, it's really easy as humans to see progress and, like, the history as things like that were like, victories. So it's like, right, Columbus discovers America, or, like, Newton, like, Galileo sees the stars, figures it out. And then Newton comes along. That was, like, hundreds of years later. Right?
Yeah.
But it looks like on paper when you read the book, right? When you read the history book. Yeah, and then we figured that out. And then Einstein figures it out. But when you're living in a day-to-day, year-to-year life of your normal human existence, those things are few and far between.
Oh, sure.
Yeah. And our perspective is, what's taking them so long?
Yeah, and I think, like, look at our technology, obviously, is, like, on leaps and bounds. And our ability to look and, like, kind of bring it back. Looking into the stars, where our cameras are better, right? They're getting higher quality. They did that huge. It wasn't even Hubble. It's the other one, right?
Yeah.
They put that huge telescope out there, and it's like, they updated the Hubble lens. Like, all that stuff is like cleaner pictures, but it's all little steps, and it does take 30, 40 years of added times 8 people, to create an actual thing that is meaningful or better understanding. So, I mean, slowly but surely, I feel like.
Just think of all the work and all the time that has gone into just getting somebody to Mars. Right.
Right.
I mean, and look at
Look at the moon landings.
The moon
We thought,
landing, yeah.
when I was a kid, oh, we'll be on Mars long by now. You
Yeah,
know? But
right.
it's hard.
Yeah, yeah. And at the same time, whoever the first people are that do make it to Mars, I mean, the idea of being the first person is amazing, and I'm sure that trumps any fear of failure.
Right.
Failure equal death, you know?
Yeah.
But I mean, that is going to be an amazing thing, and I doubt we'll see it in our lifetimes, but I mean, it would be a hell of a thing to see.
Well, you're bringing us to a nice wrap up on the topic. That's something where I want to go next, actually. One last thing on the
Mars?
Big Bang. Yeah, that's our next episode. We get into crafting. But Timothy Ferris talked about one really cool concept is, if the Big Bang is correct, then you and I and everyone you know and the atoms that make up the walls of this room and the trees and everything, we were there all together at one time. All our atoms, or whatever the early particles were. I mean, we're all brothers and sisters. We were all there, whether you're anything. I mean, we were there in an instant.
Wasn't that we're all star?
We're all star stuff.
Stuff with stars.
Yeah.
Right. But at the Big Bang, even
It's
smaller.
even
We
more-
were there.
Even more minuscule.
I remember you were there. We were talking.
Yeah, we were talking
having a
about it,
drink,
yeah.
You know, but
Yeah, I really love that thought, because in some ways it's sort of like a romantic thought, in that we are all on a biological level connected. We're intrinsically connected, and I think that's a beautiful thing, you know, and I feel like,
Yeah.
you know, we sort of need to remember that a little bit. It doesn't matter if somebody's on the other side of the globe, or, you know, or if it's a polar bear. We're all connected in one way or the other. And going back to the cycles, you know, eventually we're going to die, and our material is going to support something
else. And it
Yeah.
keeps going. That's a nice spot for us to sort of watch one last clip and then sort of wrap up. Sort of tangent off the creation of the universe, but sort of surviving death, as you're saying. This is a clip of in I believe it was 1990, Voyager 1 was leaving the solar system, and it's going to travel out into space essentially forever, 5 billion years or whatever. And what they did is they had its camera turn back one last time to the Earth to sort of snap a goodbye picture before it left. And so we got the picture back, and it was a pixel, like a pale blue dot is the Earth in the sea of space, and you maybe in a sunbeam, but that's it. So Carl Sagan reflected on that picture, and let's take a look at the clip.
Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
Wow.
Boy, he can convey a thought.
Yeah, that's a legendary clip right there.
Yeah. I think he wrote that in his one of his last books, Pale Blue Dot. He went into that, but it gives you a lot of perspective that we need to deal more kindly with one another. This is us.
Yeah, and maybe some of this, you talked about doing these discussions is discourse, right?
Yeah. I like it.
Yeah, well, I think it's interesting in that, again, I feel like it's a good and very important point. I feel like now more than ever that we have to remember, it's not like we're going to run off and populate the moon or run off and
I don't like you, I'm going elsewhere.
Right, exactly. I mean, all we have is this planet, and we're really, not treating it very well. And
we have to work together.
Yeah, it's a little scary. It's like, the old man in the sea, he's in this little boat and you have all this horrible weather and stuff, and he looks around and all he sees is ocean. It's sort of like that with us in space.
Yeah.
And
right.
I mean, we're not going to get help from anywhere. We're not going anywhere.
It's up to us.
Yeah.
Right. And the atmosphere is only so thick, right?
Yes.
Very precious.
Let's not
planet you have.
Isn't that's a scary thought, actually? Yeah.
Yeah.
And to think that we did, I mean, how, we created an issue with the ozone layer. Remember with all the CFCs?
And we also solved it.
And we solved
it. We changed our habits.
Yes.
It takes us a long time to catch up. We didn't solve it. We changed our habits. The Earth was like,
whatever. I always think of the Earth as probably another subject, but I think the Earth is like, there's a lot of you on there. Well, I mean, I don't need you.
That's right. Yeah.
It just exists.
Yeah.
Right?
Yeah.
You can destroy it, but I mean, it's not going to stop being there if humans you're just ruining your home.
Yeah.
Right? Yeah.
All right. Well, we're about out of time. Just looking at the clock. But gentlemen, thank you for being on the first episode. I enjoyed it.
Thanks for having me, Jeff.
Well, thanks. Thank you for watching, if you did. We hope you join us next time when we hope our next guest will be singer Rick Astley. Thank you. Cheers.
This was amazing.
Yeah.
Actually. Yeah.
And I love it, like, condense it. It's happened everywhere. There is no origin. It is the origin.
Yeah.
You are the. I love that part.
Yeah. Yeah.
That was a good one.
Yeah, that was a good.
What the hell is that guy talking about?
I feel like
You're the origin.
You're the origin.
But you tell me I'm the origin.
Yeah.